Sumptuous superheroes of sound and legends of LED animation. It's Professor Gallagher, and in this lesson at CircuitPython School, we're going to learn how to play sounds while also controlling and changing values in NeoPixel LED lights. This doesn't happen automatically in CircuitPython, but we'll learn some useful techniques so that we can combine tasks to run at the same time. Let us commence the awesomeness. And as a reminder, if you're new here, welcome! You may want to check out the prior lessons in the playlist to see how we got to this point. Now, the sound we're going to grab to use in this lesson is the alarm sound. Quite annoying, but it'll be useful for some fun builds in the future that respond to light changes and motion changes. So let's get that sound and get it synced up with the flashing red light that we coded in our last lesson. So open a browser, head to bit.ly/circuitpython-school-files, all lowercase. Find the alarm folder in this Google Drive, right-click, select download. Yours is probably going to download to your downloads folder. Mine asks me where I want to save. I'll save it to the desktop. Find what you just downloaded. Make sure that it's unzipped. You should see that there are two files in here, siren.wave and siren.mp3. We haven't learned how to play MP3s yet, but we'll learn them in a future lesson. And with your board plugged in, drag the folder into your CircuitPy volume. And now let's start up PyCharm and start to code. Let's change the comment up top to read alarm.py. And our first goal is to get the red pulsing animation that we did in the last lecture working with the siren sound that we just downloaded. So in PyCharm, we have our pulse up and down code that we wrote at the end of the last lecture. Remember, this pulses all of the NeoPixel lights in red, up and down, repeating constantly, and we did that by varying the brightness parameter of our NeoPixel lights. Now to add sound, rather than coding from scratch, why don't we raid the play_sound code that we wrote in an earlier lesson? So let's head to the File menu, select Open, head to our CircuitPython School folder, and find play_sound.py, and open that up. We see it's in its own tab. So first, let's grab the import statements that we'll need. If we highlight from audio core through the second except in this nested try except statement, we have code that'll work on either Circuit Playground, the Express, or the Bluefruit, and it should also work on any CircuitPython board that supports standard audio. So copy this, then head to the code.py tab, and we'll paste this in under the other import statements. And there's one more import statement that we need to add. We need to import digital I/O. That's used for the onboard speaker and the Circuit Playground boards, so we'll just head up here and add digital I/O to the import line. Then we'll head back to the Play Sound tab, and a little further down we can select from the audio setup for Circuit Playground boards that only works on Circuit Playground boards, all the way through the Play Sound function that should work on everything. Make sure you're not highlighting the while true. We'll copy that code, return to code.py, and paste it in before the pulse function. And we can close our Play Sound tab, and we'll make a few more changes. Now first, our path is going to be different. Remember, the path is the name of the folder where our sound files are stored, followed by a slash. So we just copied over a folder named alarm onto our board. So why don't we just change this string to alarm/, all lowercase. And then in the while true loop, we're already calling pulse. Why don't we just call play_sound just above the pulse, and inside the parentheses, we'll pass in the string siren.wave in all lowercase. Then we'll open the terminal, and we'll be sure we're in TO, and save. And ooh, not what we were expecting. We'll listen a bit more. And this is very annoying. So what's happening here? Well, the play sound function runs first, and that one file will play the up and down alarm sound 5 times in a row. Then it's done. Then we run the pulse up and down code, so without any sound playing, we can see the lights pulse up and down. Then we continue in the while true loop. So we play the sound first, then the pulse second, and that continues on, and that's not what we want. We want these things to run together, the sound playing and the LED pulse happening. So let me show you how to do this, and it's pretty simple. You see up here in our play_sound function, we have this section that says while audio.playing pass. Well, instead of pass, we'll say while audio.playing and call our pulse function inside where pass was. So it loops through this statement. As long as the audio is playing, it's going to call the pulse function. The pulse function will run. It will return to this while true, and if the audio is playing, it'll call the pulse function again. Now this also means we don't want to call the pulse function from within while true, because we're calling it within play sound while the sound is playing. So make sure you delete the call to pulse in while true. So now in play sound, while the audio is playing, we'll continue to call pulse, and it'll do that over and over again while the audio is playing. Then once the sound is done playing, we exit the play sound function, head back down to the while true, and we loop around and we call play sound again and start playing the sound from the beginning, and while the sound is playing, we continue to call the pulse function. Now, one downside is, once we start the pulse function running, that function has to run from start to finish before we're going to return and check to see if the sound is still playing. So if our sound ends before the pulse is done, we'll hear no more sound, but we'll watch the pulse function continue for that small amount of time until it's done running one of its cycles. But other than that, it works pretty nicely. Let's give it a try. In the terminal, TO is running. We'll save. And look at that. We've got the sound playing while the pulse is happening. Perfect. And we can tell when the sound is done playing. We might see a little bit of the animation running at the end, but then the sound is restarted and the animation is restarted and continues to run while the sound is playing. That loops over and over again. This is what we wanted. Excellent. When we save this as alarm.py to our CircuitPython school folder, close the outer tab, and we're back at code.py. And now it's time for a challenge. So modify the alarm.py code that you just wrote. Add built-in buttons A and B as two standard buttons so they don't have to be debounced. And when the code first runs, the light should be off and play sound should not run, nor should any animations run along with it. But when button A is pressed, the alarm should start with the pulse animation running along with the sound play. Now, once playing, the sound and pulse animation should continue forever until button B is pressed. Now, one thing to note about setting this up the way that we've learned so far is you'll have to hold down button B until the next cycle of play sound and pulse finishes. But as long as you're holding down button B, it will eventually turn the alarm off. Now, button A should turn the alarm back on, button B should turn the alarm off. That will continue. When you're done, save this as alarm-with-buttons.py, and this video will show you how it should work. Now notice I held my finger down on the button, but it eventually turned off. I'll hold my finger down again, and it turns off. So this might be a bit of a challenge for new coders, but try as best you can. Feel free to go back and review any of the lessons if you need to, but pause, give it a shot, and when you're ready, resume, and let's compare answers. So let's start by creating those basic buttons. Now we already have digital I/O imported, otherwise we'd need to do that. And down below where we set up our sounds, but before our functions, we'll add our buttons. So we'll first create a button underscore A and set that equal to digital I/O dot, and then it's capital D digital in out, and we pass in through the parentheses board dot button underscore A. And the second line takes button underscore A that we just set up, and we call the dot switch to input function, so this accepts input, and we pass in digital I/O dot capital P pull dot all caps down. Now once we have these two lines, we can copy them, paste them below, and change the 3 spaces where we talk about button A to button B. And then down in the while true statement, let's first get rid of this call to play sound, and then we're going to set up our 2 if statements to respond to whether button A is pressed or button B is pressed. So we'll say if button underscore A dot value colon, and then we'll say below this outdented to the same level, if button underscore B dot value colon. Now we need to put things indented below each of these if statements. Now one area where students sometimes get confused is they want to call play sound if button A is pressed. But actually what we're going to do is we're just going to set a Boolean value, a sort of flag that will be turned either true or false. And then we're going to add a third if statement that checks to see whether or not we should be playing a sound. And this is how we're going to do it. First, let's create that value to hold true or false. And why don't we call it start underscore playing. Now we want to set this initially to false before we enter the while true loop, because we want to make sure that it's false, it's off, and it's not going to play sound until we press button A. So just above while true, we'll say start underscore playing equals false. Ooh, and also before I forget, we also want to make sure that the pixels are off when we start. So we can either set them to black or we can set the brightness to 0. I'll set the brightness to 0. So pixels.brightness equals 0.0. Now back in while true, if button A is pressed, so the dot value is true, Indented below this, we're going to say start underscore playing equals capital T true. And if button B is pressed, so the dot value is true, below this we'll say start underscore playing equals false. Now here's what we're going to do with that value. We're going to add a third if statement here, outdented at the same level as the if statements for the buttons, and this is going to say if start underscore playing colon. Now remember, that value is either true or false, so if it's true, we just say if it's true, we'll do whatever's indented. So writing it like this, if start underscore playing, is like saying if start underscore playing equals true. So if it's true, indented below this, we're going to say play underscore sound, passing in that string siren.wave, and that's it. Now here's what's important to understand about the code and the way that we're setting it up. And if you don't understand it the first time we go through, definitely go back and look at the code again until you really understand what's going on. But by setting a value to true or false when a button is pressed, that value will remain true or false when the finger is lifted off the button, and it'll keep its value until the opposite button is pressed. By contrast, if we had play sound indented under button A value, then play sound would only run when a finger was on button A. So the tricky part here is knowing you need 3 if statements. One that checks to see if button A is pressed, and if it is, then we set that true-false value to true. The other checks to see if button B is pressed, and if it is, it sets that true-false value to false. And the third one actually handles what we want to do. And this one checks to see if start underscore playing, the value that's either true or false. If it's true, then we play sound. Now let's imagine what happens when we start the program. So we've got our lights off, and we have the start underscore playing value set to false. Then we enter while true, and we'll loop around here forever. And if no fingers are down, we're going to skip over these first 2 if statements. We get to the third one, and start underscore playing is false here too, so we don't do anything that's indented underneath it. And we're going to continue to loop around and around and around inside of the while true until button A is pressed. And if button A is pressed, then we set start underscore playing from false to true. Nothing happens in the second if statement where we check button B. We didn't touch that one. But hey, when we get down here to the third one, start underscore playing is now true. So this if statement is true, so we play the sound. We go up and play the sound for one pass with the animation called while the sound is playing, and then we head back down to the while true loop. And we restart from the beginning. Now, if no fingers are down, we skip over the first if statement and the second if statement, but when we hit this third one, oh yes, start underscore playing is still true. So we're going to play the sound one more time and do the animation. And we'll continue to do this over and over again until button B is pressed. Now again, you might have to hold your finger down on button B, because when you first put your finger down on button B, we may be up here in play sound and running the animation. But once that sound is done, we're going to loop around to the top of the while true. We're going to skip over where button A is pressed. We don't have our finger on that, but if we have button B pressed, then start playing is false. And when we get to the third if statement down here, if start playing, well, that's false, so we're not going to execute what's indented below. We're not going to play our sound. And we'll continue to loop around over and over again, and with each pass, we're not playing sound, so nothing's happening, until button A is pressed once again. Again, if button A is pressed, then start playing turns to true. When we get down here to the third if statement, then we call play sound. That's the way this code works. Let's see how it works when we actually run this. So open up the terminal. Hopefully you're in TO. Save. And we started. We don't see any lights on. We don't hear any sounds, but now let's press button A. And oh, listen to that, and look at those lights. Now let's press button B. You gotta hold it down, and the alarm shuts off. Now let's press button A again. It starts up, and you can see if I don't press button B, start playing is still true, so it plays the sound another time. Hold down for button B. It goes off. Excellent work. So now let's set that comment as alarm with buttons, and we'll save it with this file name to our CircuitPython school folder, and close the extra tab, and you did great work. So this was another big learning lesson. We learned that we can call additional functions from within the play sound audio.playing loop, and we also learned a technique for setting a Boolean flag to either true or false when buttons are pressed, and to use a third if statement to actually execute code you want to execute if a flag is set to true. Now, if you struggle to understand what was happening, definitely re-watch the lesson and reattempt the challenge until you have it down, because when working with electronics projects, setting buttons to turn functions on or off is a very common thing you want to do. So you really want to understand what's happening in these lessons. Now, one more thing we didn't demonstrate was how to turn off sound and light flashing immediately when a button was pressed. I'll show you that technique in the next lesson. There are a few more concepts we want to learn before we can tackle that one though, but until then, continue to hack.